Hello, everyone. Welcome back. It is now 3 o'clock, so we're going to go ahead and kick off session three, which is going to be best practices in Databricks. A couple of administrative items before I pass things over to Katie. Just a reminder that this session is being recorded. All materials are going to be made available in the CCSQ DNA portal following the conclusion of our event. Just a reminder to give us a few days to get those things turned over. And then also there is a Q&A portion at the end of our session as long as time permits. We do ask that you please remain on mute, but do put your questions in the Zoom chat. Team members may be in the chat answering questions, and then Katie may answer some verbally at the end as well. And I think with that, we are okay to go ahead and turn things over to Katie. And if I'm not mistaken, I should stop sharing and you're going to pick up, right, Katie?
Yeah, I wanted to share my
Okay.
screen.
Sounds good.
Hey, I think I shared the wrong screen.
I see best practices in
Oh,
Databricks.
okay, good. Thank you.
Yep.
So, my name is Katie. I'm with the user services team. Going to talk today about best practices in Databricks. So I wanted to talk about some of the nuances of our particular environment, lots of little things that can trip people up. But I'm going to first, I actually reorganize this so I could first talk about a couple of things that you guys might be experiencing with the Unity catalog transition and the new dedicated personal clusters. Um, and I broke this up into 4 questions. So I'm going to talk about which cluster do I use? Where do I store the data? How do I read and run the data? And then how do I create data? And because I figured you guys would be most interested in this one, I wanted to talk a little bit about which cluster do I use. And Mohammed answered this question in an earlier presentation, if you were there. But we have 2 main cluster types. There's interactive, and we had the shared org clusters that we were using before, and those have been discontinued, so we don't have those available anymore. They're gone. We are using those dedicated personal clusters. And then we also have jobs clusters, which are kind of lightweight and good for your kind of production ready code that you might be using. So you want these interactive clusters for development. The dedicated clusters are available. I have a few links here. And I did want to demo one thing that people have been asking a lot about is since you have the dedicated cluster, you can install libraries on your cluster. There's a link here with instructions on how to do that, but I wanted to demo it just real quick. So if we go over to compute, you can, I already opened it, but it's here in this new tab. So I have a cluster here that I'm going to click on, and I already created it. You can go over here, create compute. So to put libraries on your cluster, you want to click on this libraries tab. You go over and you can install new. So there's different options here. The ones you might be most interested in are this PyPy option. So you can put some package that you might pip install in one of your notebooks. And this way you can just install it on the cluster and you don't need to pip install it. But be mindful of what version you're using and which packages need to be installed that might not be readily available if you're sharing with your teammates and things like that. The 2 libraries that I've included in the notebook are ones that I think a lot of people are using. They're available in Maven, and you could paste it right here, the same thing that I put in the notebook. You could paste it in this coordinates box, or you can go search packages, SAS7B DAT, and you'll notice that it'll say no results found. We have Maven Central selected here. You can go down and click Spark packages, and then you see this Sourfong one. I'll click select, and then that also can fill in this box for you. And you click install, and it runs and installs this in your on your cluster. And that's pretty much these what your dedicated your dedicated interactive clusters are good for developing code, running hopefully subsets of data while you're developing and things like that. And then you can move to these jobs clusters to run your full job on your notebook. The jobs clusters, they're lightweight, they cost a lot less than the interactive clusters, and they're a really good go-to for notebooks that are ready to go. If you go over into workflows, there's also job runs down here that can get you to kind of the same place. But workflows, sorry about that, will take you to a page that looks like this. I have a favorited thing, and so it's not so cluttered. But you may see, one or more jobs here that have been set up. I just have one as an example, because one of the nice things about having a job that you've scheduled is that you can come to a page like this and click on one of your runs and say, oh, I want to look at that notebook and see what happened, because maybe you have different parameters that you enter in the notebook. You want to see, oh, what was that value of that one cell where I ran an analysis or something like that. And these notebooks, um, you can click on each run and click on your notebooks and see what they look like at these different points in time. So that's also one of the nice things about having a job that's ready to go, that something that you might run regularly. And sorry, it scrolled all the way down. So that's the jobs clusters. I'm going to move on to question number 2. Where do I store the data? The best practice is to store data in the workbench. If you're still in SAS, or if you've just come from SAS, you may think workbench and workspace. We've used those interchangeably when we've talked about workbench and S3 space. But when we're talking about Databricks, the workbench and the workspace are different. So we have the S3 workbench for a place you can store data. Our CDR data catalog, which you saw in the prior presentation, that's where you can also store data. And then I wanted to make a special note, only programs go in the workspace. So the S3, you saw some things about that, is you can store files. If you're not sure of your S3 path, you can ask your core or your colleagues. And that S3 path will look something like this. So here's one that I have access to, and you actually have access to view this cell. So if you ran this, it should run fine. %FSLS will give you this nice display. This is all there are lots of data sets in this this S3 workbench, example data. This is another way that you can write it. I just wanted to give you lots of little example codes in this notebook. So here you see those again. You can also access S3 Pass from UFM, which is this go anywhere. If you go sign in to look at all your little charms that you might have, it looks something like this. And you'll have some kind of org folder. This one is my org folder, and then this one's the one. This is how we get the data up. You don't have access to this on UFM. Here it says workbench. We call it workbench. We have example data. And then you'll see all the things that we just listed in here. So this is where you can upload data, and you download your reports that you create on Databricks. And the CDR data catalog is another place that you can store data. Whenever you create a table, you may want to save it in a nice centralized place, which would be this catalog here. It looks something like this, where you can come to the catalog, you can search for your schema, and this schema is CDR PSA community. You guys have read access to this also, because this contains a lot of our example data that we use for our presentations. And then if you have your org's schema, you can come and look at the same sort of thing, and you and your team can have tables that you use for various reports or journal or articles or papers and things like that. And it's really useful to have that structured, centralized place to access things. Again, only save notebooks to the workspace. Those are the workspace in Databricks. It'll start with workspace in the path, You have a user folder. There is a little more information in, sorry to scroll up and down on you. In a KB article that we have, there's a link in this notebook that says why you shouldn't save data in the user folder, and it has a little more information on this. So again, do not store data in the workspace. The best practice is to store data in the S3 and in schemas in the catalog. So question number 3 is, how do I read and run the data? So you know where the data live, and now you'll be able to access and run it after we talk about this section. And the best practice right now is to use mounts to access data in your S3. And the mounts more effectively use distributed processing. That's the other nice thing about the catalog, is if you have a table in the catalog, you don't need to mount any S3 path to most efficiently read that data in. But when you use the S3 path, the best practice is to create a mount and to access the data that way, because it will efficiently distribute it for you. We have supported languages, Python, R, SQL. You heard Scala mentioned, and I'm just mentioning it here so you know that it's a thing, but I'm not going to talk on it too much. Then I have a special SQL example I want to show you and talk about. So here's the section about mounts. These optimize that file access from the S3 workbench. I wanted to show you this example cell here. I put a little extra in here. I have this try except block, and this is a Python cell. So you don't need this. The only thing you really want to pay attention to is dbutils.fs.mount, and then you have your S3 path. I call it S3A for a reason, I'll tell you in a second, and then the path that you call your mount name. So that mount name has to start with -mnt, and then you give it some unique name because the whole workspace is able to see this name. That does not mean they can access any of your stuff. It's just that name is visible. And so that all of those mounts in the workspace, they can persist a long time. So I'll show you how to unmount so that it does not stay in there for a while. You want to use the S3A for the start of your path. So let's say, for example, I want to get this CSV file from my S3 storage. Here's the whole path to the org and then workbench. And we have this created folder, example data, and then this CSV. So for the mount, I'm only going to the example data folder. And then I create this mount. And then I can list it. And this is the exact same listing that you got from the dbutils FSLS that's above. So what I showed you before, it had these same folders, and I was listing the S3 path instead of the mount, but they're pointing to the same place. So you can see it here. And then this path on the left side, this column, they'll look a little different because of the way you asked for it. Sorry, I don't know what happened there. So then the Python and R are probably the most common languages that we use in our environment. The Databricks platform supports those. Of course, you can also use SQL, and you'll use a lot of SQL queries whenever you call data from the catalog. And just as an excuse to give you extra example code, I have a number of cells here where I read in from the catalog. I'll read in from an S3, and then we do a couple transformations, and we are going to join those two things together and then just display something. So this data set is a Washington state, the electric vehicles that are registered there. And this state column actually contains more than one state because the vehicle may be in a different state than Washington. And then this S3 location, I mounted it, so we're able to use this in across our different cells. So the SQL cell, the Python cell, and the R cell can all still see what this mount location is. And I just want to put the state name on that data set that I just showed you with the EVs. The first cell is Python. The screen jumped a little bit. So this first cell is Python. And we're reading the two data sets in, then we're doing a couple transformations, joining, and then we display this select distinct. And we're ordering it by state so that the other two cells, the one with R and the one with SQL, will have the exact same output in the exact same order. So these are the states that are in there. And then the state name was attached on there also. So that's just some example code just for fun. Then there's one in R, and I hate to mention this, but you may have an issue with this, but we're working on that. This Spark Read CSV. But this gets the same result. And then the SQL, if you wanted to do it in SQL, you could do it like this, and it would get you the same result. So feel free to clone this notebook and play around with it and look at it more closely. I'm going to skim over some stuff because I have 20 minutes and I made more than 20 minutes of stuff because I want to give you guys as much as possible to look at and read and use as an example. The next thing I want to talk about, I have a really cool example that came from one of our data camp presentations in the fall. And I love this example because there's so much to it that I think is really useful to share with our best practices. So the point of this one is select only the data that you need. It's very useful when you are reading in data. So this is a Python cell right here. See, says Python. And we're using spark.sql and some SQL query text to read in some part A data. And the example here, we're just reading in what we need. We're reading in only the columns that we need, and we're only reading in the rows that we need, because this will really help you when you are, especially if you're developing your code and you're just working on a smaller subset, but also whenever you have your final code, you want to just bring in what you need, and that can help you you won't run into as much errors, out of memory errors in your while you're working on this kind of stuff. So the other thing that I wanted to show you that I think is really nice about so you have Python and R available to you in Databricks, and here's a way that you can use Python to help you with your SQL query, because Python has F strings. So you see this F here in front of the quote. Then we're using a for loop to fill in this, we're making a really long text string. So these four pieces here this F string this is how you refer to a variable in an F string with these curly braces. And these four variables here are filling in 100 columns that you're calling and giving an alias at the same time. So up here is how we put that together. The claim diagnosis code underscore, and the I means you'll go for 1 to 25 because it's 26 but not inclusive, as diag 1 through 25. And then you do it with this present on admission, you do it with the procedure code, and then the perform date. So this is I love this example because yeah, it just has all these nice pieces to it that I think make it a really fun example. And since it's PII, I'm just sharing a row count in the output because you may not have access to it, so you may not be able to run that cell itself, but it's a good example. So the next question, how do I create data? And this is the last one, so I'm sorry, I'm running a little bit over the question time, but I will zoom through this one. So how do I create data? The one thing I wanted to point out is that data files saved to the S3 workbench are going to be in a folder. So something that kind of throws people a little bit is when they save data with Spark, you say, okay, I want to save .csv. And then they go look and they say, but this is a folder. Now let me show you an example.csv. This is something that is saved in one of the notebooks somewhere that we use as an example. I can't remember. And it was called example.csv, but and I'm sorry, I switched over to UFM. So this is an S3 bucket, and the CSV file has a bunch of stuff in it, but there is a CSV here. And one thing, if you're creating a report that is just a table like this, that you want to share out out with somebody, there's example code in here how to make it just one CSV. And that's what we have here. You can rename this something human readable, not a bunch of numbers. And then you can, share that as long as it's something that is shareable. I know a lot of groups create reports that they share out that are like that. But of course, only share data that are allowed to be shared, not anything confidential that's not shareable. And one of the reasons for this, if you want to learn more about the background on why Spark does this, you can look at our Office Hour 2 about Databricks file management. That's a really good one. So here's the example code for how to create a single CSV. This coalesce one, make sure that your data frame, like this example here, we have some data frame. We're saying put it all in the driver node. So it's all going to one thing. And then we write it to a CSV. That allows it to create one CSV file. And then it will look like this. This is a listing. So it's basically what you just saw in UFM, but here's a listing. You had some extra stuff, and then there's a CSV. And if you don't use Coalesce, that same thing is like 5 different files. And you can take that and put them together kind of manually, or create a program that will kind of put them together also with like a script. Because there are CSVs that some orgs create that are a little too big, but that's when we suggest that you use a jobs cluster to do this coalesce one and then write your CSV. All right, so the last things, we unmount that mounted path to clean up the workspace. And then that is kind of all the little bits that I wanted to share with you. In conclusion, we kind of answered the following questions. Which cluster? The interactive clusters are for developing your code, using those subsets, and the jobs clusters are for doing the heavy lifting to do the full analysis on the full data, and using your tested notebooks that you've developed and to do your production code. Where do I store the data? Store your data in S3 or the catalog. How do I read and run it? Use the mounts and SQL statements. You'll use Python and R also. Those are, good tools that are available to you. How do I create data? Save your files to S3, and you can save tables to the CDR also. I hope you will check out these resources. I have the link to the portal Code Commons, and then here's the older link that has you may have seen before, and then some other other extra things. And then there's a bonus at the very end. Thank you so much for coming to listen to best practices. I'm gonna check out the chat. Or I'm sorry, Julia, I'll hand it to you because you will read the questions.
Hi, Katie. I actually think at this point so far, they have all been
Okay,
answered.
good.
So we're up to date.
Okay, good.
The team's been keeping up with those.
Thanks, everybody.
We can just give it one more minute. I know we have 2 minutes
Sure.
remaining in the session, to see if anyone has anything additional.
And then Tim is giving a talk about logging tomorrow. So there was a question about logging. So tune in at 1 p.m. Eastern time for a presentation on logging. I'm excited to hear it too. Yeah, storing
Okay.
HTML outputs in S3. Sorry, Julia.
No, you're good. I thought I saw one, but it wasn't. It's just a response.
Yes, and get your S3 workbench path from your core. And sometimes your colleagues will know also and be able to share that with you on your team. That S3 and S3A are just different protocols. And the S3A is the one you need for mounting. And then the S3 you can usually get away with everywhere else. But there's a more detailed explanation in the chat.
Okay, I think at this point we have no other questions coming in, and we're just about at time anyway. So with that, a big thank you to Katie, and thank you to the team members who had also been helping in the chat, and thank you to all of our participants who were asking questions and attending our session. So with that, we're gonna have a short 5-minute break, and then we're going to move over to our fourth session of the day. and pick up from there. So please join us back at what time is it now? Join us back at 3:30, and that'll be for working with beneficiary in the cloud big data, and that will begin, like I said, at 3:30. Okay, so